Welcome to this video on natural numbers, whole numbers, and integers. Let's begin. This video will answer the following questions. What is a natural number? What is a whole number? And what is an integer? Before we begin, I want to explain the importance of this diagram. So what you're going to do is I want you to pause this video in a minute and you're going to place the words animals, dogs, and mammals in the appropriate circle. Then unpause the video to see if you are correct. Okay, so what this diagram is saying is that this small circle is entirely contained in this larger circle. So the most specific of these words should go in the smallest circle. So this most specific is dogs. So all dogs are types of mammals, right? They're warm-blooded animals. So mammals, so there are other mammals that are not dogs, right? For example, cats and humans, right? There's lots of other examples. That's not the point. But the idea is that all dogs, right, are all dogs are mammals. So again, if you know that something is in this inner circle, dogs by definition are also mammals. Then mammals, right, are all types of animals. Now, there are other animals that aren't mammals. For example, birds, right? Birds are animals, but they're not mammals. So that is the relationship we're trying to indicate by this particular diagram. We're saying that everything in this circle is also this, and everything in this circle is also this. So let's do this one more time. Now we have food, chocolate, and candy. So pause this for a minute, see if you can fill it in, and then we'll go over it. So I would say that chocolate, oops, I spelled it wrong. Chocolate is a type of candy, right? There's other candy that isn't chocolate, like, Starburst. Right, Starburst is candy, it's just not chocolate candy. Okay, so all chocolate is a type of candy, and all candy is a type of food. Again, there is lots of food that's not candy, like, things you should actually eat, like chicken. Chicken is not candy, but it is food. Can eat it. Okay, so again, the relationship among these three circles is that everything in this circle is this, and everything in this circle is this. Okay. So why did I do that? That was kind of silly, right? Well, the reason I went through that is so that you understand the relationship that's indicated in this diagram so that when we put it in terms of mathematics, it makes sense. So what is a natural number? Natural numbers, the way I think of them are counting numbers. So think about the way you learn to count, or if you have children, how you taught them to count. What number do we teach people to start counting at? Well, we start counting at 1. Right? That's what we teach kids to count at. 1, 2, 3, and so on. So those are natural numbers. So natural numbers is going to go in the smallest circle. Okay, again, it's 1, 2, 3, and so on. Okay? So what about whole numbers? What's a whole number? Well, whole numbers are all natural numbers, and then we start adding 0. So we have 0, 1, 2, 3, and so on. Okay? So all natural numbers, by definition, are also whole numbers. So how can I remember what is a whole number? Well, one way I remember it is that 0 itself is kind of like a whole, right? So I remember, okay, well, whole numbers are all the natural numbers plus 0, because 0 is a whole. And then lastly, what about integers? Well, integers you still have 0, 1, 2, 3, and so on. But then we fill in the other end, which is the other side of these numbers are negative numbers. Okay? So that is integers. Okay? So let's look at these sets. Okay, notice that all natural numbers are also whole numbers. Do you see that? Do you see how every natural number by definition is a whole number? Right? And you see how every whole number by definition is also an integer. But notice also that there are some integers that are not whole numbers, right? For example, -2. -2 is an integer, right? But it's not a whole number. Likewise, there's really only one number that's a whole number that's not a natural number, and that is 0. Okay. So based on this diagram, and I'll recreate it really quickly here for you, let's fill out the sentences below. So it says, based on this diagram, all natural numbers are also whole numbers. Okay, again, because this small circle is completely contained in this larger circle and this other circle here. Okay, so all natural numbers are also whole numbers. All natural numbers are also integers. Okay, and again, that is the relationship we're trying to communicate by this this diagram. Okay, also, we know that all whole numbers, by definition, are also integers. Okay, so true or false, all integers, that's these guys, are also whole numbers. Is that true? Well, it's not true because, look, integers contain negative numbers, and those are not whole numbers. So this is false. True or false, all whole numbers, that's this, are also natural numbers. Well, it's false because 0, by definition, is a whole number, but it's not a natural number, so that is false. True or false, all integers, that's these guys, are also natural numbers and whole numbers. Again, that's false. So let's take a minute and practice identifying whether each of these values is a natural number, whole number, or integer. Again, remember it can be more than one, and it probably will be more than one in several instances. So I want you to think about filling in this diagram. There's 2 ways to do it, right? We could go across like this, right? We could ask ourselves, is -5 a natural number, a whole number, or an integer? Okay, and you can totally do that if you would like. But I would like to suggest that it might be easier in your mind to go down, because if I go down in a column, right, like this, then I'm only really remembering one thing, which is what is a natural number. So what is a natural number? Well, a natural number is counting numbers, right? 1, 2, 3. So is -5 a natural number? No. How about 1/2? No. 3.4? Also no. How about 17? If I counted 1, 2, 3, could I eventually get to 17? Yes, I could. So I'm going to put a check mark here at 17. How about 0? If I count 1, 2, 3, will I ever get to 0? No. How about 21? Yes, I could count up to 21. How about -7? Nope. How about square root of 2? You can type that in the calculator if you want. It's like 1.414, so on and so forth. Again, I'm not going to get there by counting. So there's no check mark there. So in this list of numbers, the only ones that are natural numbers are 17 and 21. Okay. Now let's think about whole numbers. So with whole numbers, right, first of all, let's remember that all natural numbers by definition are also whole numbers. So without even thinking about it, I'm going to put a check here and here, because I know that if a number is a natural number, it's also a whole number. Then remember, we're only adding one other number to the set of natural numbers, which is 0. Is 0 anywhere over here? Well, it is. 0 is right here. So I need to make sure that I put a check mark by 0. So again, that's the only other number here that is that is a whole number that's not a natural number. Okay, lastly, we have integers. So let's remember what integers are. So integers are any number that's positive, negative, or 0, but again, it has to be, it can't be a fraction or a decimal. Okay, running out of space here. 1, 2, 3, so on. Okay, so let's go through our list. So let's start with -5. Is -5 an integer? Yes. Right. If I went in this direction, -1, -2, -3, I could get to -5. So yes, it is an integer. How about 1/2? In this list, could I ever get to 1/2? No, because it can't be a fraction or decimal. How about 3.4? Also no, can't be a fraction or decimal. Okay, so what about 17, 0, and 21? So remember, these numbers, by definition, all natural numbers are whole numbers. All whole numbers are integers. So I don't even have to think about this. I can just go ahead and put check marks here, because I know that if it is a whole number, it is also by definition an integer. So now we have our last 2 numbers. How about -7? Could I get to -7? Absolutely. So -7 is an integer, And again, the square root of 2, if you type that in a calculator, it is a decimal, so it is not an integer. And so we're done. So I want to encourage you, again, to pause this video, do this on yourself, do this by yourself, sorry, and then unpause it to see if you're correct. So this is a little bit different. It's not just asking for integers, it's asking for positive integers. So one way to think about this is just to go through and cross off all the negative numbers. Because if something is a negative number, then it's definitely not a positive number. Okay? And then also this is negative, so it can't be any of those. Okay? What about 0? Is 0 a positive number or a negative number? What do you guys think? Well, 0 is neither a positive or a negative number. So if 0 is not a positive number, then we can also cross out 0. So now we only have 4 choices left. We have 4, 2/5, 6, and 2.5. So again, if you go back here, remember your integers, they can't be fractions or decimals. Okay? So now let's cross out all of the fractions or decimals. So it can't be this or this. Therefore, the only positive integers in this list are 4 and 6. Okay? So what about this next one? It says circle all the negative integers. Okay, so if it's a negative number, it can't be positive. So let's cross out the positive numbers. It can't be any of those because they're positive, and we are looking for negative numbers. What about 0? Is 0 positive or negative? Well, it's neither. Remember, 0 is neither positive or negative. Since it's not negative, I'm going to cross it out as well. Okay? So then remember with integers, right, we are looking for numbers that are not fractions or decimals. So let's cross out all the numbers that are fractions or decimals. So we'll cross out that number and that number. So that only leaves us with 2 options, -8 and -7. So as you're going through this and thinking about it, sometimes the easiest thing is to eliminate things that don't qualify instead of to circle the things that do qualify. Last but not least, circle all the integers. So integers, remember, cannot be fractions or decimals. So I'm going to cross out all the fractions and decimals. Okay, so what's left over? What's left over is 0, that's an integer, 1, -4, -9, and 10,000. Those are all integers. And then the question is 0 an integer? And the answer is yes. So the last thing we want to do is to briefly review how to plot numbers on a number line. So notice we start at 0 here. Okay, so let's go ahead and start plotting these numbers. So let's start plotting 9. So 9 is going to be right here. Then let's plot -2. So -2, we start at 0 and we go left 2 units. So -2 is going to be right here. Then we have +17. Positive 17 is going to be right here. And then we have +5. That's going to be right here. And -5 is going to be right here. Okay, and then now we're being given locations on the number line, and we want to figure out where they are. So if I start at 0, 1, 2, 3, go 3 units to the right, then that means that C is at 3. So C is 3. Okay. So if I look at letter D, I start at 5, 6, 7. So D is at 7. Okay, if you look at A, you can see that already that's at -15. And B, you're at -10. You move to the left 1, so that would be -11.